This is Statistical Rethinking, second edition, and we are just starting chapter 15. So we're in the easy questions, and we'll look at 15E1 and 15E2. I see I have a little indexing error. Let me fix that. Okay, so these two questions are related. So what we're going to do is we're going to look at the Oceanic tools model from chapter 11, which is just reproduced right here. And we're going to do two things to it. In 15E1, we're going to allow for measurement error in that value right there, the log of population. So you can think of this as a value, call it whatever. You could think about it as just being p, but it's the log of population. And then in 15E2, we, instead of allowing for measurement error, we're going to allow for missing values for log population. Okay, so let's take these one at a time. So if we want to add measurement error, what we're saying is that our observation here is polluted by noise. So there's some signal and some noise in our measurement for population, or in this case, log population. Maybe around, or well, doesn't matter. We have some kind of error in our measurement there. And so what we want to, so we no longer want to regress on log population, right? We want to regress on, okay, because we don't know the exact value of log population, we want to, create our linear model over the distribution of values for log population, okay? And so, in other words, we need to add measurement error in there. So what we're going to do is we're going to remove this, okay? And we're going to instead use something like this, okay, as our new value, okay? And so I'm calling this new value the log of p true, okay? So this is a parameter. Maybe I could have given it, a Greek letter or something, but this is fine, okay? So and so now p true represents the actual value, but we don't know the actual value, and so we're going to try a bunch of values for p true. Now, what values are we going to try? Well, we're going to try a distribution of values that are being informed by, among other things, the actual observed value. Okay, so notice that we've shipped log population to now being a parameter. Well, how do I want to say that? It's not really a parameter. It just has a distribution. Okay, of which p true. If we call this a normal distribution, we're saying that the log population has the most likely value of being p true, okay? But there's going to be some noise around that here, signified by sigma p, and then we give sigma p its own distribution as well. Okay, so I hope that makes sense. Maybe let me try to state it in a different way. Okay, once we acknowledge that log population has measurement error, then we have uncertainty about that measurement. And so we want to capture that uncertainty. And the way that we're doing that here is to assign a distribution to log population. Okay. And so, here we're using normal because I think that's what we use in the book, and I think it's just also conceptually easier right now. Okay. And we're saying that any observation centers on the true value of, right, so if we were to be able to remove all of that measurement error, then our observation centers on the true value with some noise, okay, or at least our best guess of the true value, or our best guess of logPi centers on p true, okay. So there's that. So now we're going to go to 15E2, and no longer do we think that we have measurement error in log population. Instead, what we think is that, or maybe we confirm this, is that there are missing values of population or of log population. Okay, and so so we need to somehow account for those missing values. Okay, so this is kind of the same trick, but notice that no longer do we assume measurement error. So log, so we're still regressing on the actual observed value. Okay, but once in a while, the computer's going to go through and notice that there is no logPi value. Okay, at which point it reverts to a distribution for the logPi, right? Because if we don't know the value, well, we know that there is a value, and it probably abides by some distribution that we can estimate. Okay, and so now logPi again has a distribution. Okay, and so whenever the computer finds that we're missing a value, it will then resort to drawing many samples from the distribution of p bar with a standard deviation of sigma p, right? And then each of those values will be tried for logPi, right? This is what multiple imputation is. Okay, so I think that is good.